Sciences Department's seminar series. And the speaker today is Alan Robock, who is a distinguished professor in the Atmospheric Sciences group in the Environmental Sciences Department at Rutgers University. I have such a long list of accomplishments that I actually had to print it out for Alan. So his BS in meteorology from University of Wisconsin, followed by an MS and PhD at MIT. His main interests are nuclear winter, climate intervention, i.e. geoengineering, and volcanic eruptions and climate. His H index as of today is 99. So we're hoping that you're gonna get to 3 digits very soon. That must be an incredible accomplishment. And I just have a couple of quotes. So Alan is not afraid of controversial topics such as the following. So he had a blog called Modest Proposal. And the subtitle is "The most efficient method of quickly reducing the global population and solving the global warming problem is by nuclear war." So I think he's going to talk more about this today. Alan is also the co-director of the Rutgers Impact Studies of Climate Intervention at Rutgers, of course. He's a fellow of the American Meteorological Society, the American Geophysical Union, among others. He's been the editor and is the editor of several journals, such as the Review of Geophysics and the Journal of Geophysical Research Atmospheres, Journal of Climate, and Applied Meteorology. He's also a very devoted educator. He's been the director of the Meteorology undergraduate program at Rutgers and is a current member of the Atmospheric Sciences graduate program. And as a personal touch, Alan and I have an important colleague in common, Dr. Bob Bornstein from San Jose State, who actually married both of us. Not to each other, obviously, but he performed the wedding at both of ours. So here's Alan for you, and thank you very much for joining.
Thanks so much, Christina. When Christina came to give a talk about wind power at Rutgers a couple of years ago, I said, I have to tell you, Christina and I were married by the same person. So.
I thought I would replicate the joke with you.
So thanks. Christina mentioned the modest proposal that I wrote. Of course, it was modeled off after Jonathan Swift's A Modest Proposal, which wasn't meant to be taken seriously. So, but people always ask me, you know, if this smoke from nuclear war causes cooling, that's going to solve the climate problem, right? So I'm going to talk about global famine after nuclear war, mainly based on a paper we have in review now at Nature Food. And a lot of this was fun.
Sorry, if you can stay a bit closer to your,
so they can hear
you better. That's all. You're still in control of that. Just
okay.
Closer, yeah.
Okay. And a lot of this funding came from the Open Philanthropy Project, which is from Facebook billionaires.
Can you share some?
Okay. I know. Okay. So first of all, I want to tell you that Rutgers is older than the United States, like the University of Delaware. And because of that, the namesake Henry Rutgers owned slaves, as did many of the early presidents. And the land on which Rutgers sits was taken from the Lenni Lenape Indians, and enslaved people built the campus. Since we have reminding ourselves of that a lot more these days. This is the obituary of Sherry Rowland. Those of you who are atmospheric scientists know that he got the Nobel Prize in chemistry along with Mario Molina and Paul Crutzen for their work on the ozone hole. This was in EOS. And Sherry said, what's the use of having developed a science well enough to make predictions if in the end all we're willing to do is stand around and wait for them to come true? He also said, is it enough for a scientist simply to publish a paper? Isn't it a responsibility of scientists, if you believe you found something that can affect the environment, isn't it your responsibility to actually do something about it? Enough so that action actually takes place, if not us, who, if not now, when? And so these ideas are what inspire me to do this work. That's why I'm doing this work. We've discovered a danger to society and we want to tell people about it. So this talk is going to be talking about nuclear winter theory. And then, of course, we can't test the theory in the real world. So I'll talk about a few analogs we use to test it, and then policy implications, and then doing something about it. So I've joined something called the Physicists Coalition for Nuclear Threat Reduction out of the American Physical Society and Princeton University. I'll talk to you about that at the end. By the way, this is the first time I've given a talk in person in 2 years, so it's really exciting. I did give a talk at the AGU meeting in December, but it was up on a stage far away from people. So this is really nice to be able to do this again. The last AGU meeting before that was in San Francisco. And this is a picture of some of us old guys who worked on nuclear winter. Rich Turco, Brian Toon, with whom I still work, and Tom Ackerman, me, and Gira Stenchikov, who was part of the Russian team that worked on nuclear winter. And there's a couple other people, a little hard to see. There's Carl Sagan and Vladimir Alexandrov, who also worked on it, or were no longer with us, unfortunately. Because of the funding from Open Philanthropy, we put together a team to work on this. And so these are some of the people on our team. Cheryl is an oceanographer, so is Nikki. Julie models firestorms in cities. Lily does crop modeling, and Jonas does too. And Josh, Chuck, and Mike do global climate modeling. And I also have some new people in my group. And so we have this lab which does a lot of work on geoengineering, but also nuclear winter. And so these are my students and 2 postdocs. And a lot of things we focus on are how will crops be affected by climate change? And we're in particular talking about aerosols in the stratosphere, which are different from global warming. First of all, they cause cooling. A lot of the models weren't tuned for that. Second of all, they destroy ozone, so you get more ultraviolet radiation. They also have changed the ozone chemistry of the troposphere. They also give more diffuse radiation and less direct radiation. All those impacts are important for crops, for agriculture, for plants, but they haven't been baked into the models yet. So we're working hard to try and add that to the community land model, which is part of the NCAR climate model, and then be transferred to other models. So we've done published a lot of papers on our work in places like Science and Proceedings in National Academy of Sciences and JGR, and even these are the last 3 years, but not many policymakers read those. So we're trying to figure out how to get the word out more. But if you want to find out more about our work, it's all these papers are online. You can go to my website or just Google my name in Google and you'll come to it. So here's the story. Here's our beautiful planet. But after a nuclear war, it might look like this, with a cloud of smoke covering it from the fires that would be started by nuclear attacks on cities and industrial areas. And it would be heated by the sun and move into the southern hemisphere and cover the world. And if there was enough smoke, the temperatures would get so cold at the ground over the land that temperatures would get below freezing, and even in the summertime. And we call that nuclear winter. There would also be less precipitation. The hydrological cycle would be weakened because it would be colder. And of course, it would be darker. And all these things can affect crops. And as I mentioned, there'd be more ultraviolet if the smoke wasn't thick enough, wasn't too thick. So here's a history of the number of deployed strategic nuclear weapons from the invention of the nuclear weapon up to now, a couple of years ago. It's about the same now. So there was a nuclear arms race, and now it's over. And first of all, this is the total for all the nations. Can somebody tell me how many nations there are that have nuclear weapons? US and Russia have more than 90% of them, but what about, how many are there altogether? 18?
I thought 8.
8? Okay, the answer is usually if there were more people, usually the consensus is the best predictor, best for. It's 9. So in addition to the US and Russia, there's France, England, and China. Those are the 5 permanent members of the UN Security Council. And then there's India, Pakistan, North Korea, and Israel, although Israel doesn't admit it. So why did the nuclear arms race end? So in 1982, Paul Crutzen and John Birx wrote a paper on what would happen after a nuclear war to tropospheric chemistry. mainly ozone. And they said those are photochemical reactions. And by the way, there might be fires and smoke and there'd be less sunlight, and that would affect the result. And you know, that might cause some climate change. And Paul got the Nobel Prize along with Sherry Rowland and Mario Molina. And people said, what? So they started to sit down to try and calculate what the climate response would be. And the next year, there was a paper by a Russian group, Alexander Fenstenchikov, and by an American group, Turco-Toon, Ackerman, Pollack, and Sagan, who gave the name Nuclear Winter, paper in Science. And in fact, in 1982, I went to the AGU meeting in San Francisco, and there was a talk, Climatic Effects of Nuclear War. I went to the talk, there's a little sign on the door, this talk's been canceled. It turns out 3 of them worked for NASA, NASA Ames, and NASA director told them, you can't use the term nuclear war in our work because it'll hurt our funding. And so they said, what are we gonna call it? Okay, forcing and response, nuclear winter, a brilliant naming job. So that's what they called it. So and then next year, Covey, Snyder, and Thompson at NCAR and I published a paper looking at more climate modeling. All got the same result, that there was nuclear winter and it could last for a while. And so then the arms race ended. I assert that we were part of the reason for it. So when we do research, you know, how do we do it? We get some data, we have theory, we build a model, and we do calculations, and that's how scientists do work, research. Historians, they just ask people, what did you do? So that's what we did. And by the way, another theory is the Soviet Union ended, but the Soviet Union didn't end for 5 more years. So that was over long after the arms race was over. And by the way, although the number's been going down, there's still 10,000 deployed nuclear weapons in the world, plus a lot of, the problem of nuclear weapons has not been solved yet. So Ronald Reagan and Mikhail Gorbachev were the 2 people that ended the arms race. He was president of the United States. And he said, a great many reputable scientists, and he called us reputable, are telling us that such a war could end up with no victory for anyone because we would wipe out the earth as we know it. Think back to natural calamities back in the last century, in the 1800s, volcanoes. We saw the weather so changed. There was snow in July in many temperate countries. And they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about? The whole nuclear exchange, the nuclear winter that scientists have been talking about. And Gorbachev said, models made by Russian and American scientists show that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was a great stimulus to us. So in both cases, the scientific results from either side were the same, and they accepted the science. They almost completely got rid of all nuclear weapons in Reykjavik, but they didn't. That's another story. That was 40 years ago. So why am I even bringing it up now? I want to ask 2 questions. Although the Cold War and the nuclear arms race are over, could the remaining nuclear arsenals still produce nuclear winter? And as I mentioned, there's 7 more countries now with weapons. What if there was a much smaller nuclear war between, say, India and Pakistan? What would that do? And so the answers are, if you want to stop after the slide, you can. Yes, we can still produce nuclear winter, and it would last a decade. And if there was a war between India and Pakistan, the temperatures wouldn't actually get below freezing, but it would still have a huge impact on agriculture and the availability of food. And I'll show you the calculations we did about that. The direct effects would be horrific. Tens of millions of people would die, but the global effects would be much larger because the smoke would stay up there for years and travel around the world. So this is a map done of Japan and by the US Army. And these are all the cities that were firebombed in Japan during the summer of 1945. This is a story that's not much in our history classes. On March 10th, and this is Tokyo, they have, it's a little hard to see, the names of the equivalent sized cities in the US are here, New York. 2 planes flew at night and they painted an X, a burning X with napalm, and then over 300 planes came in and firebombed the city with incendiary bombs. More people were burned to death in 24 hours than ever before or since in history. And this was the policy of General Curtis LeMay, who was the Air Force general. And they tried to bomb military targets in the daytime, but their bomb sights weren't very good, and they got shot. So they said, we're going to do it at night when they can't see us. We'll just burn the cities. And you know, but you're killing innocent people. Well, you know, everybody's got a drill press out back there, part of the war effort, so it's okay. So every 3 days after this, they were burned a few cities. And when it came to the 68th and 69th cities, that was Hiroshima and Nagasaki. And in those cases, they only needed one bomb for each city rather than lots of them. But the policy of killing people, killing innocent people, was already part of the US policy. And they killed about 800,000 innocent civilians. So on August 6, 1945, a 15 kiloton bomb killed about 150,000 people. 15 kilotons is 15 explosive power, 15,000 tons of TNT, trinitrotoluene. You may have heard a couple years ago about the mother of all bombs they dropped in the Middle East. It was a 10-ton bomb. This is 15,000 tons, 1,000 times stronger. And this is small by today's standards. In fact, if you dropped one of those bombs every 2 hours, 12 times a day, every day, starting in 1945, you still couldn't use up our current nuclear arsenal in terms of its explosive power. This is the airplane that did it. It's called the Enola Gay. It was named after the mother of the pilot, Paul Tibbets. And this is where it was stored at a warehouse at the Smithsonian, the front and the back half of the plane. This is a mock-up of the bomb, the uranium bomb that they dropped. That's me, but when I had some hair and it was black. Now it's on display at the Smithsonian Annex out by Dulles Airport. Now, this is what the mushroom cloud looked like from dropping the bomb. This is a pyrocumulonimbus cloud started from the fires that were ignited 3 hours later. The amount of energy in these fires was 10 times the amount of energy in the bomb itself. So the whole city burned and it pumped smoke high up into the air, into the lower stratosphere. A lot of people identify this as the mushroom cloud, but this was not. This was the cloud from the fire. And a lot of the survivors remember the fires. Here's one picture drawing, here's another drawing of one of the fires. And this is what Hiroshima looked like afterwards, after they cleaned up the streets. So everything burned except for a few stone buildings. 2 days later, we dropped a bomb, which is the plutonium bomb. This is a picture I took in the Nagasaki Museum it's called Fat Man. It was a spherical bomb. This is a picture of Fat Man and the bomb. And this is what the mushroom cloud of the 20 kiloton bomb that they dropped on Nagasaki 3 days later. And that's what Nagasaki looked like. Now, we don't have that many examples of cities burning, but you don't need a nuclear weapon. In 1906, there was an earthquake in San Francisco, and it burned the whole city down. And Jack London, the famous author, was asked to write about it for a popular weekly magazine called Collier's. So within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower visible 100 miles away. And for 3 days and nights, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration from out on the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. That's a classical description of a firestorm. And this is what we think would happen after every city that's burned, that's bombed with a nuclear bomb. This is what San Francisco looked like afterwards. A few stone buildings were left. So this is the total number of nuclear warheads in the world. This is done by the University of Nagasaki. They do this every year, and this was from June last year. So these are the weapons of Russia, the US, and the other 7 countries. A red symbol is 5 land-based missiles, bombs. Blue is 5 submarine-based ones. Green is 5 on airplanes, and gray are ones that are on a shelf waiting to be retired. It's kind of hard to see these others, so let me blow it up. The US and Russia each have about 6,000 nuclear weapons, and the other countries, either on the UK, they're all on submarines. The other countries have them in different places. Have a couple hundred. China 350, France 290, UK 225. India and Pakistan have about 150, Israel 90, North Korea 40. Now, if you believe that nuclear weapons are going to deter an attack on your country, how many nuclear weapons would you have to put onto the capital city of your enemy to deter them?
One.
One. Okay. Maybe you need two in case the first one didn't work. So a couple hundred is more than enough. Why do the US and Russia still have thousands? What could you ever do with them? And there's only 9 countries with nuclear weapons. Why are there so many other countries that don't have them, that could make them if they want? How to make a nuclear weapon is no longer a secret. Enriched uranium or plutonium is available if you want to get it. There's at least 40 countries that have enough material to make bombs. They've chosen not to. What can we learn from them? Okay, here's a picture taken from the space station. It's a little hard to see because all the shit. Anyway, you can probably see it. This is a border between 2 countries. Can somebody tell me where this is?
North and South Korea.
North and South Korea. Well, no, because if it was North and South Korea, one side of it would have no lights at all.
It was hard to tell with the light fluid. I thought that's
Okay, I'll tell you. This is India and Pakistan, and each of these lights is a huge city, huge. So you may not have even heard of them. Karachi, 24 million people. Faisalabad, 4 million. And so about 15 years ago, we did our work on nuclear winter, and we went on to other things. But about 15 years ago at AGU meeting, I ran into Rich Turco and Brian Toon, and they said, you know, somebody asked us what would happen if India and Pakistan had a nuclear war. Back then, each of them had about 100 nuclear weapons. And Brian said, I told them not much, but then I calculated how much smoke there would be. And I thought maybe it'd be 5 million tons of smoke. And I said, oh, that's not nothing. Who's going to calculate the climate response? Well, we thought maybe you would. So that's what I did. So we asked the question, or my student Luke Oman did, who was working on volcanic eruptions with the NASA GISS model, and he just put smoke in it, soot instead of sulfate. It worked fine, even though they had a soot model that was made for tropospheric pollution, but it worked fine. So what if India and Pakistan had a nuclear war? Imagine a skirmish in Kashmir escalating due to poor communication, misunderstanding, panic, and fear. I should add something else on here. Do you know what happened 9 days ago? India launched a cruise missile at Pakistan, and it landed in Pakistan. And fortunately, it didn't land on anybody or even on any building, but it didn't have a bomb on it, didn't explode. And India didn't even tell them about it for a couple of days until the Pakistanis announced it. And they said it was a mistake. They were doing some maintenance and it fired by mistake. That doesn't give you much confidence in India's ability to control their nuclear arsenal. And there have been actual, a couple of years ago, there was a fight, an Indian fighter plane went into Pakistan and was shot down, and they ended up giving the pilot back. So and there have been people dying along the border. So it's not hard to imagine until recently that this is probably the most dangerous place in the world for a nuclear war might start. So we decided to use 100 15-kiloton bombs. We assumed that that's what the size that they could make. Those are the easiest to make. And we took half of each arsenal. We put them on the places that would burn the most in each city, in each country. And it would be horrific. 20 million people would die from the direct effects. Half of all people that died in World War II. And places would be made radioactive for a long time. About 5 million tons of smoke would inject in the upper atmosphere. And then we calculated the climate response. So we used the NASA GISS Model E model, 4 by 5 degrees horizontal resolution, which is kind of low resolution by today's standards, but it had a stratosphere and a mesosphere, so it could pump the smoke up and remove it. And so here's a movie. Now, this is the Tropopause. So this shows the vertical distribution average globally, and that's a map showing where it would go horizontally. So the smoke would be heated by the sun and lofted into the stratosphere to the top of the stratosphere. And so it would last for e-folding lifetime of 7 years. It would last for years and be blown around the whole world. It's not like volcanic sulfate aerosols, which go right into the lower stratosphere, and they're clear, so they don't get nearly as much heating, and they have an e-folding lifetime of about 1 year. And then we calculated what the global average temperature change would be. So this is the blue line is the observed global warming that we all know and love and work on, and this would be instant climate change. And it would be to temperatures colder than the little ice age. So in fact, it would be global climate change unprecedented in recorded human history. Now, people said, oh, well, that model is imperfect. So a couple other groups did the same calculation. A group in Switzerland using their model, Sokol, and a group at NCAR using the NCAR model, and got the same result. Global cooling for more than a decade from less than 1% of the global nuclear arsenal. But it's worse than that. This is a Trident nuclear submarine. Each one can carry 96 nuclear weapons. And typically the size of the weapons today are 100 or 500 kilotons, not 15. So one Trident is equal to 1,000 Hiroshimas, not 100 that I was showing you before. And we have 14 of them. That's about half of our arsenal, so 25,000 Hiroshimas, and Russia's got the same thing, so that's 50,000 Hiroshimas. So there was always a controversy in the 1980s, was nuclear winter really correct? Because they used a single one-dimensional model to do the calculations, and the NCAR 3D GCM only ran for 20 days and didn't have an ocean, didn't have a stratosphere. I used an energy balance model. So we said, okay, let's put it back into our state-of-the-art climate model and redo it. And so we used the NASA GISS model. We put in either 50 or 150 million tons, teragrams of smoke. And what can produce that much smoke? So that was the standard nuclear winter scenario of 40 years ago, where they used only a third of the arsenal of the US and Russia. And we said, well, how come we can still do it with 4,000 weapons, which is what's in the New START Treaty now? And it turned out that they put one weapon on every possible target in their enemy country. And they still had a huge pile of weapons there. They said, okay, let's put 2 on in case the first one doesn't work. They still had 9 weapons for every possible target. So if they used even a third of the arsenal, they'd be bouncing the rubble. So now with one precisely targeted weapon, we can still do the same thing. It could still be done. And so here's a movie. Now the smoke is much thicker, but it has the same lifetime and covers the globe. It just has larger cooling. So we looked at a year later, if the war started in May, June, July, August, year 1. This is the surface temperature change. And temperatures would fall by 20, 30 degrees Celsius, which is the same as was found in the 1980s by the Russian model, but they didn't have an ocean. But even over the ocean, it would cool a lot. And we said, okay, let's take a place in the Ukraine where there's a lot of agriculture. I don't know if there's going to be this year, but there usually is a lot of agriculture. And so this is a time series of the daily minimum temperature at that point. And the black is the control run. So in the summer, get up to 20, 25 Celsius, 70, 80 degrees Fahrenheit, below freezing in the winter. But if you put the smoke in here, temperatures would go below freezing and stay below freezing for at least a couple of years. So really it was nuclear winter. Recently, with our new funding, we've been running WACM, which is the whole atmospheric community climate model, much higher resolution, much better physics. And so we published a paper 2 years ago in 2019. We compared the results, and this is temperature anomaly for WACM is the red, GISS is the blue, almost exactly the same global cooling, 8 or 9 degrees, and almost the same precipitation reduction, about 50%, 40-50% reduction in precipitation. Because in WACM, they have a model called KARMA, where the aerosol particles can grow and get larger, they fall a little bit faster, so the lifetime is a little bit shorter, and so the temperature recovers a little bit faster. But for 5 years, you have nuclear winter, so it doesn't really matter what happens after that. Now, Pakistan, when we did our calculation 15 years ago, each had 100 weapons. Now they're trying to make their arsenals bigger. And so we did a calculation by 2025. What if they had more weapons, more powerful weapons, and some of the targets were bigger, had grown, so there was more smoke. And we calculated what would happen. So we calculated that India would use 100 weapons, Pakistan 150. It could reach 50 to 125 million people, direct fatalities, and 16 to 36 teragrams of black carbon in smoke. So if you now look at the global temperature change from these different scenarios, the green is the one for the US-Russia that I showed you before. The blue is the 5 teragram case for India, Pakistan. These are what we think would now be the possibilities for India, Pakistan. You could still have several degrees cooling. Remember, during the last ice age, when big ice sheets were covering North America, global average temperatures were about 5 degrees Celsius colder than normal. So it's ice age temperatures for a few years. So if you plot this now on the global warming, you have to rescale your plot. And this is from the GISS model, 5 teragrams, 50, 100, 150, and this is ice age. So what we really care about, though, the most important impact of climate change is food, and water goes along with that. How much would agriculture change? So how would nuclear war affect agriculture? Well, it would be darker, less sunlight, it would be colder, and there'd be less rainfall, and there'd be lots of other things, toxic chemicals. You couldn't, the seeds are designed for a current climate, so you couldn't plant them. You might not have fuel for machinery, water for supplies, pesticides, and enhanced UV. So far, we've just analyzed these 3 major things: temperature, precipitation, and sunlight. And we have a paper which we submitted to Nature Food. Unfortunately, they took a long time to get us a review, but one of the reviews was really good. And so we did a lot more work and made it better. And we just resubmitted it last week, the revision. I told the editor, you took a long time. Can you speed this one up? I think there's an urgent thing we want to talk about now. So, but I'll tell you what, I hope it will be accepted very soon. So we use the community land model, the CLM from the NCAR climate model, to calculate crops. And it has these main grains: corn, rice, soybeans, and wheat. And we used, so the question is, if you can't grow crops on land, can you go fishing? So we calculate how the fish would change too. We published a paper on that already using a model called boats. And then we looked at eating animals. We looked at different scenarios. Would you still feed livestock, or would you take the food and eat it yourself? And so about half of cattle and sheep are fed by pastures and half by crops. And so we got data from the Food and Agriculture Organization, FAO, for every country. How many animals do you raise? What food do they use? How much food do you import? How much do you export? And we did analysis for every country and then added it up. This was done 40 years ago, ocean before and ocean after, including stronger storms on the coast because the land would cool more than the ocean. So this is the change of crops. This is the for these different scenarios. So it would be a change in the amount of total calories available in the world, almost 90% for the nuclear winter and 30–40% here. The fish wouldn't change as much because the ocean wouldn't cool as much, and so the impact wouldn't be as large. But we use less than 10% of our food comes from fish. And so you add these two together, this total looks just like this. And we also calculate grass. And so the grass change in the areas where there's agriculture, it would be a little bit larger reduction than crops and marine fish. So if you wanted to keep your animals, you still wouldn't be able to feed them very well. So I've learned a lot about food from this. So the average diet, 2,855 kilocalories per capita per day. About half comes from grains, wheat, rice, maize, soybean. About 31% comes from other vegetables, 18% from livestock, and a very small amount from fish. And if you look at where this food that you grow goes, for corn, the darker part of the wedge is what goes to food. Only 18% is eaten by people. Most of it goes as feed for animals. For rice, most of it goes to people. For soybean, most of it goes to animals, and for wheat, most of it goes to people. And so if you add it all up, 42% of the crops, plant-based products, go to food, 24% for poultry and pigs, 8.8% for ruminants, the ones who also eat pasture, 18% is lost, and then a little bit others. So we have the data for all of these things for every country, and we were able to add them up for each scenario. So the scenarios we used were a livestock scenario. We looked at year 2, by the way. We assumed that if the war occurs in year 1, there's only about a 60-day supply of food that people have stored, unless you have a well-armed fallout shelter with many years of supplies. Not many people have that. So we assumed that in year 1, all the food would be gone, and you'd have to depend on growing food. And if, say, the war occurs in December, then when I say year 2, I mean year 3. So anyway, after the stored food is gone. And so one scenario was livestock. You would reduce the cereal, vegetable, and marine wild catch, and marine fishery effort would be business as usual. No change. We would feed all the livestock and eat them, and livestock feed would go to animals. But then what if we gave some of the livestock, and some of it we just used their food for humans? And what if we got rid of all the livestock, didn't raise livestock anymore, and a portion for human consumption, because you can't eat all the food that goes to animals? And we boost the fishery effort, at least for a couple of years, but that pretty soon you use up all the fish. So these are scenarios we used. And so here's a graph of the partial livestock case, where 50% of the feed is used for humans and 50% to feed livestock. And this is the number of calories in each country for 5 teragrams, 16, 27, 37, 47, 150 teragrams. These are like the India, Pakistan cases, US, Russia cases. The green means there's enough food on the average for people to not die from starvation. If it's yellow, you're going to be losing weight, eventually starve. If it's red, you're going to starve very quickly. So it turns out, like for this case here, in many countries, especially at higher latitudes, it would be a hugely devastating after you use up all the food. And so then we said, well, what if we do this sort of draconian thing? We know how many people are going to be alive at the end of year 2. So we're not even going to feed the people that are going to die. And we just use all the food for the people that are going to be alive. And this is the percent of the people that would still be around. And so if it's pink, it's less than 50%. If it's red, it's less than 25% for these different cases. And then you ask, well, all right, how many people are going to die? So this is the millions of people that would starve to death at the end of year 2. For the 5 teragram case, with the livestock case, over 50 million in China, but other countries not so many. 37 teragram case, more than 100 million in the dark gray in the US and Russia and China, big countries. And for the nuclear winter in most countries, it was interesting. We looked at what happened to Australia. Australia is still green. It's because they grow mostly wheat and they don't have many people. And they're closer to the tropics, so the climate change isn't as large. So we did some graphs of the global population, the calorie change in the global population for these different scenarios. And so this is the number of people that would die. So I just put it in a table. For 5 teragram, for the livestock case, 27 million people would die. But for partial livestock, you could 260, 350 million people would die. For the 37 teragram, 2 billion people would die. And for the nuclear winter, 5 billion people out of a total of 6.7 billion, which is when we had the data for. So it wouldn't be human extinction, but most people would die, even for happened with a war between India and Pakistan, but it also could be a war between India and China or some other country. It doesn't have to be those 2 countries. It's just that for that amount of smoke. Now, this is the temperature change in the vertical for 10 years for the 5 teragram case. Temperatures will go about a degree colder at the surface, but there'd be huge heating of the stratosphere because the smoke would be absorbing sunlight. And this would destroy ozone and let more sunlight, UV, through. So what would happen if there was more UV? It would cause skin cancer, it would affect crops, and it would affect fisheries and ocean ecosystems. So we had a paper that was just published last year. Chuck Bardeen was the first author, where we put a much more detailed calculation of UV into the climate model to where it affects ozone. And this is for the India-Pakistan case. There would be an increase in DNA damage and in UV. But in the US-Russia case, because there'd be so much smoke, even though all the ozone would be destroyed, the UV couldn't get through the smoke and wouldn't get to the ground until years later, except for this one, which is UVC, which doesn't get absorbed by the smoke and causes cancer. So what about analogs? Well, it gets cold in the winter. We have a gut feeling it gets cold at nighttime. So we have a feeling for that. I already showed you firestorms and fires, Martian dust storms, asteroid impact killed the dinosaurs, forest fires, Saharan dust, volcanic eruptions. I could give you a whole lecture on all of these, but I'm just going to show you two examples. One of them is smoke. So in 2017, there were big wildfires in Canada, and the pyrocumulonimbus pumped the smoke into the lower stratosphere, and then it was heated by the sun and lofted farther up by 10 kilometers. And we used the same model we used for nuclear winter to simulate this, and it was able to do it. And so that's how we got this published in Science. And it was detectable for more than 8 months, and it rose from 12 to 23 kilometers. So here's one of the figures that shows some of these curves are observations from satellites. Some of these are model results. They're all on top of each other. In the first 10 days, you would rise, and then it would be blown around the world and last for a long time. And then 3 years later, there were much worse fires in Australia around the end of the year, Christmas time, and they pumped 3 times as much smoke up in the stratosphere, and that lasted for more than a year. People are still writing papers on that. This is the Tambora volcano that Ronald Reagan mentioned. It erupted in 1815 and caused a year without a summer in 1816. And this is Harold or Sigurdsson, a volcanologist, standing up on the rim. And so I'm just going to show you one figure. This is from a book by Stommel and Stommel. If you know, Stommel is a famous oceanographer, but he and his wife wrote a paper about the little ice age, about the year without a summer. And this is the temperature in June in New Haven, Connecticut. And then Gillen Wood wrote a book, Tambora, the eruption that changed the world. He said for 3 years following Tambora's explosion, to be alive almost anywhere in the world meant to be hungry. And there was famine in Europe, in parts of the US, in India, in China, in Yunnan province. So here's the conclusions of the science part. A nuclear war between any nuclear states using less than 3% of the current nuclear arsenal would produce climate change unprecedented in human history. Such a small nuclear war would produce global starvation with massive increases in UV, and the current arsenal can still produce nuclear winter, killing most of humanity. So how do you feel? It's really depressing to think about this. People ask me, how do you work on this? And I say, well, I want to prevent it. That's what I'm trying to do. So the natural reaction is to go out of here and forget that I had told you this, because it feels so bad. As Mark Twain said, denial ain't just a river in Egypt. But my reaction is to try and do something about it. So I want to prevent something like this from happening. And this cartoon was drawn before anything happened in the Ukraine, but it has the White House, and St. Basil's Cathedral is not where they have the button. It's across the street, Red Square in the Kremlin. But, so other people have tried to do this, tried to limit what happened. And so this might make you feel good. And the closest we ever came to a nuclear war was the Cuban Missile Crisis. But Khrushchev and John Kennedy were so shocked by what almost happened that a few months later, they signed the Partial Test Ban Treaty. So maybe there'll be a reaction like this after the Ukraine war is over, that people will come to their senses. And then there's a Threshold Test Ban Treaty, and then the Comprehensive Test Ban Treaty. And even though the US hasn't ratified it, there hasn't been a US nuclear test since 1992 and a Russian one since 1990. Now, there's also treaties that limit nuclear weapons in different places. So the Nuclear Non-Proliferation Treaty is trying to to prevent other countries from having it. But it has an Article 6, which commits the signatories to have a treaty on general and complete disarmament, which they've been ignoring that. But there've been these are treaties on the number of weapons. Anti-ballistic missile treaty, the U.S. withdrew. The strategic arms limitation treaty, and the only one that's really still in force now is the New START treaty. And Obama and Medvedev, who was president in 2010, signed it in Prague, and it committed each side to have a maximum of 1,550 weapons deployed and strategic. That's on intercontinental weapons. It's not about tactical weapons in the battlefield. But each bomber counts as one because they don't know how many weapons are on it. So maybe each side has 2,000 weapons. And there are intrusive inspections where Russian inspectors come to the US and American ones come to Russia, and they open their silos and satellites can look in. So when Trump was president, it has a provision that it could be extended by 5 years. It was going to expire February 21st, 2021. So a month after Biden became president. But Trump refused to extend it. Even Putin wanted to extend it. Anyway, when Biden became president, they extended it. So there's 4,000 nuclear warheads, but that can still produce nuclear winter. Now, this is a map of the world. Every place that's blue has no nuclear weapons. There's no nuclear weapons in the Southern Hemisphere. South Africa had a program. The Israelis helped them, but they dismantled it. Brazil and Argentina did some research, but decided not to have it. There's 9 countries, 1 in North America, 2 in Europe, England and France, and 6 in Asia. The yellow ones are ones that are in NATO or some other treaty with the US that thinks that our weapons will protect them. And the orange ones actually have US nuclear weapons based there, in Turkey, Italy, Germany, Belgium. But a lot of the places have treaties. Kazakhstan, as soon as they broke away from the Soviet Union, got rid of all their nuclear weapons, and because a lot of them had been tested there with a lot of local damage. So these are the treaties that did that. The Latin American Treaty, nuclear free zone, outer space, seabed, South Pacific, Southeast Asia, Africa, Central Asia. But the most important one is the Treaty on the Prohibition of Nuclear Weapons. In 2017, this was passed by the General Assembly of the United Nations, and it bans nuclear weapons for the countries. Ryan Toon and I wrote a paper called Self-Assured Destruction. So people think it's mad mutual assured destruction. If you attack me, I'm going to attack you. But turns out if one country attacks the other one doesn't do anything, everybody in the first country will die from the climate response, because 50 teragrams of soot is more than enough. So it's really sad. And if you threaten to use your nuclear weapons for deterrence, you're acting as a suicide bomber. Why would anybody believe you? It's really crazy. You threaten to use them, but you can't. So they say, oh, okay, but we're therefore deterrent. It turns out that nuclear weapons don't deter attacks from pandemics, from hackers, from cyber warfare, from terrorists, and they don't stop other nations from attacking you, even though you have weapons. There's many examples of that. The Soviet takeover of Eastern Europe, the Algerian War, France had nuclear weapons. The Yom Kippur War, Israel had nuclear weapons. The Falkland Islands, UK had nuclear weapons. Afghanistan, who won these wars? Who won the Vietnam? Nuclear weapons didn't help you. Oh, but no, you got it wrong. What I meant is they're to deter attacks from other nuclear nations. Okay, well, it's true. There has not been another nuclear war since the entire nuclear arsenal was used on Japan in 1945. But why? Is it because of deterrence, or is it because of other things like there's a general decline in violence, there's a growing international collaboration, there's democracies, there's NATO, UN, EU. So we don't know, it's hard to quantify the role of deterrence, but if you believe in it, it has to work perfectly forever. There can't be any mistakes. You can't have any accidental launch of missiles from India like we just saw last week. And there's been so many other examples where we came much closer to nuclear war by accident. So the closest was in the Cuban Missile Crisis in 1962, When I was in Cuba, I took this picture. They have a little outdoor museum. This was, there were 3 regiments with 36 operational rockets with 36 warheads. Each one was a megaton, so twice as big as any current one, 77 times powerful than Hiroshima. This was donated by the Soviet government. And there were also strategic weapons that nobody knew about. And so on Black Saturday in 1962, there were cruise missiles pointed at the United States. Nobody knew about them. There were wartime radio frequencies signaling war in Soviet Union. A US spy plane entered Soviet airspace and unfortunately got out. But a U-2 spy plane was shot down over Cuba that day. And then there was a Soviet submarine off the coast of North America, and the US Navy was dropping depth charges on it to try and get it to come to the surface. But they thought they were being attacked, and they had a nuclear submarine that nobody knew about. And because of Vasily Arkhipov was one of the 3 people that had to decide whether to use it, he said no, they couldn't actually use it. So it came very close that day. And I had the very surreal experience of being invited to go down to Cuba and talk about nuclear winter. And I met Fidel Castro twice. And the second time, I sat across the table from him for more than 3 hours. He told the whole story of his life, including the Cuban Missile Crisis. And he said, you know, Russia, there was a Soviet ship arrived every day with supplies for us. So when they asked to put nuclear weapons here, I couldn't say no. But Cuba was one of the first countries to sign the treaty to ban nuclear weapons. So this is me. I had a Rutgers, first time I didn't have a president. I didn't know I was going to meet him. I didn't have a president for him. I wrote a Rutgers baseball cap, and his son Fidelito, his son Antonio, his wife. My student Juan Carlos Antuña, who got his PhD with me at Rutgers, went back to work in Cuba. And so President Kennedy was president then. He said, the world is really an impossible place to manage so long as we have nuclear weapons. And he also said, every man, woman, and child lives under a nuclear sword of Damocles, hanging by the slenderest of threads, capable of being cut any moment by accident or miscalculation by madness. Weapons of war must be abolished before they abolish us. This was 1961, 61 years ago. And then Martin Sherwin wrote, the real lesson of the Cuban Missile Crisis was that nuclear armaments create the perils they're deployed to prevent, but are of little use in resolving. And it's just by luck that we haven't had a nuclear war since. There've been a lot of cases where they thought they were being attacked, but it was a faulty sensor or a faulty, somebody put a training tape in the computer. So I think we're lucky we haven't been at a nuclear war. And the only way we can reduce the threat very simply to start with. We could take the US land-based missiles off hair trigger alert. They're meant to fire if they're being under attack. And what if the signal is wrong? We can give the sole presidential authority to launch nuclear weapons. It doesn't have to be one person, it doesn't have to be quickly if you ever want to use them. We can change our policy to no first use of nuclear weapons. All options do not have to be on the table. And we can get rid of our land-based missiles because that makes the world very unstable. So the International Campaign to Abolish Nuclear Weapons organized a number of conferences around the world to talk about the humanitarian impacts of nuclear war, both the direct effects, the Hibakusha people that suffered from Hiroshima, and also the indirect effects that we work on. I went to a couple of them. This is the one in Mexico. And then in 2017, the United Nations General Assembly passed a treaty to ban nuclear weapons. They didn't put it through the Security Council because the nuclear nations could have vetoed it. But now's the hard part, getting people to sign it. And the treaty came into effect after the 50th country had ratified it, which was a year ago. And now 59 countries have ratified it, but the 9 nuclear nations are still trying to ignore it. And the Nobel Peace Prizes have been given in the past for people trying to solve the problem of nuclear weapons, including to Linus Pauling, International Physicians for Prevention of Nuclear War, the International Atomic Energy Agency. And in 2017, it went to the International Campaign to Abolish Nuclear Weapons. For its work to draw attention to the catastrophic humanitarian consequences, which is our work, and for its groundbreaking efforts to achieve a treaty, which they got through in 2017. And so they're still trying to get other countries to sign the treaty. I like the symbol that they drew for them. This is the ICAN symbol. And Beatrice Finn, who runs ICAN, when she accepted the Nobel Peace Prize, she said, The story of nuclear weapons will have an ending, and it's up to us what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where mutual destruction is only one impulsive tantrum away. This was during the time when Kim and Trump were arguing about whose button was bigger. So, but John Kennedy knew this 60 years ago. So my policy conclusions: nuclear weapons can be used if they exist. A nuclear war could start tomorrow by accident, hackers, computer failure, bad sensors, or unstable leaders. Arsenals do not deter attacks from non-nuclear states. The only way deterrence will work is if states believe other states are willing to kill themselves by using their weapons, and there's a guarantee there'll be no unintended use. So the only way to solve the problem is to get rid of the nuclear weapons. So we formed this physicist coalition for nuclear threat reduction. It has over 500 members now, and we, our team, including me, go around and give talks about it in universities and physics departments where there's a congressional member who's on one of the important committees like armed services or foreign relations. And we have, we support fellows to do research, and we have webinars about different issues, and we write, and we have a lobbyer. The American Physical Society lobbies for certain activities, and so certain policy activities. So one of them was in 2020, 2021, no resumption of nuclear testing, extending the New START treaty. These happened. Now we're advocating for no first use policy, and we're talking about eliminating launch on warning, eliminating land-based ICBMs, made presidential sole authority. So if you want to join, physicistcoalition.org. You don't have to be a physicist, you don't have to be an American, and you'll get email once a month about interesting information. And they even made a QR code you could scan if you want. So I'm just going to end now. Carl Sagan was one of the people who worked on nuclear winter, and they said to him, "Carl, don't you want to keep our nuclear weapons for deterrence?" And he said, "For myself, I would far rather have a world in which the climatic catastrophe cannot happen independent of the vicissitudes of leaders, institutions, and machines. It seems to me elementary planetary hygiene as well as elementary patriotism." See what a great communicator he was. Unfortunately, died when he was 62. So I think elementary planetary hygiene demands that we eliminate nuclear weapons much faster than the current pace. And here's a picture of our beautiful Earth. I hope it ends up looking like this for a long time to come. If you want more information about my work, you can go to my website, and all the papers are there, PowerPoints, everything. Thanks very much.